All right, it's going to get kind of geeky, but it all relates to this. This is the Gospel of Thomas, was written by doubting Thomas, and he was the scribe for Jesus, wrote down his sayings as he was alive and speaking them. He said, whoever discovers interpretation of these sayings will not taste death. And that's in quotes. Jesus said, those who seek should not stop seeking until they find. I'm going to tell you something. You can keep looking and looking and looking. When they find, they will be disturbed. When they are disturbed, they will marvel and will reign over all. And after they have reigned, they will rest. Now, I don't know what that means, but I can tell you one thing right now. I have seeked, and I am seeking, and I will continue to seek, because it seems like there's just nothing that ever ends. Now, you can watch whatever you want to watch, but it's going to get a little geeky. Now, and then the person says, Jesus said, know what is in front of your face, and what is hidden from you will be disclosed to you. There is nothing hidden that will not be revealed, and there is nothing buried that will not be raised. Remember these words. These things are for you to see, and for others as a test. I remember those words, because that's the message I got. So you can see it for whatever you want to see. I think I understand what I'm seeing. Anyway, it's going to get geeky from here on, because I want to prove what I'm saying. Another way I can do it is to prove it with actual evidence. Okay, my friends, it doesn't get any deeper than this. I keep saying that, but this time it's as deep as it gets. We're going to go into Enoch. We're going to go into the Gnostic library that was discovered 1945-ish, right after the Holocaust. Now, I am a scientist, so don't start laughing that, oh, I'm looking into religion and it doesn't fit with science. Well, let me tell you something. It fits exactly with science. And believe me, I understand this stuff very, very well. This is 50 years ago. And I did this for my whole life. So, and I have books and books and books and books and books and books and books of this stuff. So, forget about just laughing at me because I'm just a religious fanatic. I am not a religious fanatic. I am a person that investigates things, and I have investigated atomic theory, and they agree it is not correct. The Bohr model's wrong. It's been agreed by the Royal Institute in London and everybody, literally. If you look it up, they say there's no way they can account for the particles that they see. And I can, because electron flood theory states that the smallest particle that exists is an electron. You see, it's like that right there. All right, there's a strong side and a weak side. And the weak side just rolls away and the strong side explodes. Now, once I discovered this, and then I discovered back to back, they look like this, and they're photons. These will electrocute you because they want to be partnered up with something. These are partnered up with something. They'll bang off you. They'll create light and a little bit of heat and so forth. Now, but they also explode through a Venturi and accelerate. Shown it a million times. I'm going to show it again, obviously. Now, I am going to talk about Enoch because with electron flood theory, the reason I have to do this is because of electron flood theory. I read all of these ancient texts. I thought, boy, what a silly thing this is. This is insane. I mean, these are the giants. He was talking 2.5 miles tall. Well, yes, absolutely, 100%, no question whatsoever. We've got them. So don't laugh about that at all. My stuff is DNA certified. It's only a couple 100 feet tall. But Tyson's, I'll show you, he's got a membrane 6 feet thick, a membrane. A bilipid membrane. Look it up. And then the dragon in Morocco is 1,000 miles long. And there's a ton of these things on the surface of the earth. And the earth, I now believe, was a biological creation. It's just a creation of biological creatures. Now, I don't know what else to say. That's all I can find. There is nothing else. And I believe that the only thing that particles of light can construct is biology. I don't think they just come down and they turn into certain molecules all by themselves. I think bacteria literally is the constructor of almost everything, using their enzymes as catalysts. I'm not kidding you. It's just phenomenal what I have discovered from electron flood theory and from this. Listen to this. This is blow you away. I mean, if it doesn't blow you away, I don't know, you're just unblowable away. Enoch was the seventh from Adam. He was the great-grandfather, I believe, of Noah, but he was before Noah. So all of these things he wrote were before Noah, and Noah had no idea about these things. He wasn't born. Now, at 365 years old, God took Enoch. He must have liked him. And because he took him up there in the first place, and then he sent him back to earth to tell everybody, you got issues. Now, on the earth at this time, the giants, he said, were 3,000 ells tall, which equates to 2.5 miles. And they were monsters, and they ended up eating everything that man could produce, and the men and the people and everybody, and drinking their blood and all this kind of crazy stuff. No. So they had to be flooded, and then God sent a flood which drowned them or starved them. Now, a lot of them were stuck in the mud. That's why the feet are in the mud. Now, everybody says, oh, there's only 1 foot. Yeah, a lot of times there is only 1 foot, because the other foot is so deep in the mud, trying to push the other foot out. The only one stayed above, and so eventually the guy drowned or he starved, whatever happened. And then the salt waters mixed with the flesh of biological creatures. Now, not wood very well, and not bone specifically. Bone outside the flesh would erode right away. It would go into the salty waters. But inside the flesh, it becomes stable with a process. It's called nucleophilic invasion, nucleophilic reaction, nucleophilic bonding, whatever, however you want to call it. But it's replacement. Like this is a bone. All right, now it looks like a bone. Well, it is a bone. Now, the reason it's looking like a rock and it looks like dirt, but it's a bone, is because it has stabilized in aqueous solution, aqueous watery, and there's always things moving around in there through the waters. They have, the molecules will just sort of roam around looking for somebody to attach to that makes them comfortable and the other thing comfortable. And this is what happened. It became stable as a rock. Now, it's as stable as a rock. Now, the periosteum is here, there's the coating, the fascia, the marrow. That's a piece of bone right there. That's the last of the bone. In the microscope you can see it. That is the last taste of bone in this bone. So they don't stay bones. And that's what they're looking for. Oh, there's no bones. No, there is. That's a bone. It transitioned. Just like this is a goose's head. All right, there's the pattern of the feathers on his head. Somebody was complaining I didn't show the neck well enough the other day. You see that? There's the neck. Now, you have to put it in the right light to see the neck, but maybe you can see that, maybe you can't. But to me, it's quite obvious where the neck is. Now, it's laying flat like this after the flood. The head and the neck would come straight back like this, and the body and so forth, and it snapped right at the neck. So that's the neck right there. You can see it. You can see the round neck. See it? That's the neck, and that's the beak, bill, whatever you call it on a goose. I think this is a goose. I don't know. It could be something else. To me, but this fascia and every coating that's on the surface, it's the fabric of life. This looks like, and the guys, oh, it looks just like a bone. Yes, it does. I'm sorry, that's just the fabric of life. They all look the same. Although sometimes, like this obviously doesn't look like that. And the reason is that was in a different pH and a different solution and for a different amount of time and a different heat and a different this and a ding to the bip to the boop. You don't have any transition metals left in this. Well, what does that mean? What you have is the fabric of a heart. I believe this is a heart, at one time was. Now, this is the fabricy tissue. But all of the transition metals, which normally are in there, see, like, you see all those different colors? Those are transition metals. All right. Now, this could be a lung, I don't know what it is, but it's some form of an organ. And this was soaked for a long time in some kind of chemistry. It could have been acid, it could have been salt, it could have been whatever. But all of the attachable particles in there, which is, all transition metals and all the colored things are what they call ligands. Ligands are little things that will attach to other molecules if they're flowing by. It's in your bloodstream. That's what they are. They're ligands in your blood. Blood holds and zinc and this and that and all these different metals in your body are ligands, and they hold on to other particles. They flow through your body, and then they pop them off to the tissues, to the collagens, to whatever. So they're always flowing, and they're always given and taken. That's what a ligand is. And in here they're gave. So this, obviously some fresh water that was either salty or acidy, or maybe it was just fresh in a very long time. But it didn't bring in any new transition metals. All right, I know I'm getting a little off the beaten path here, because we're going to get back to Enoch and about the seven heavens and the different Schumann frequencies, because this is good. It absolutely blew my mind. And I thought I was way past that, and I am not. And we are going to look at the Gospel of Thomas, 1945, discovered. And when you hear the things that Enoch had to say, and what has happened, and what I have discovered, and we have discovered as Mudfossil researchers, it's just unbelievable. Now, I've been studying the Schumann frequency, and I've done a bunch of videos on it, and I say, this is very strange. Schumann's frequency starts at 7.83 hertz. It's exactly the hertz of the human heartbeat. Boom, 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 boom. 7.83 hertz it really is a biostable vibration of molecules. And I show you how these molecules have to vibrate at a certain frequency to be stable with a certain number of particles. And if it doesn't have this correct frequency, I think it's going to change molecules to some degree. And they did some experiments on this, and I'm going to show this shortly. I got all kinds of things. Yeah, here it is, synchronization of the human autonomic surface. Anyway, we're going to get into this. But Enoch was seventh from Adam, very, very early in God's creation. But already it was so out of control. God said, come up to heaven here. I want to talk to you. And he did. He summoned them. And they came down and they grabbed him. They said, come on, let's go. And rip, up he goes. Now, he goes all the way up to the seven heavens. And I'm going to leave it very short because I want you to start thinking about this, because I'm going to show you the Schumann frequencies and why I say these relate to these seven heavens. Now, Enoch was left. First of all, God told him, go back down and tell everybody that you're going to be gone, and or so somebody told him up there, or somehow he had to go back down and tell everybody that he was leaving. You got to watch the thing or listen to the book of Enoch. It's all written about it. So it says exactly what he did and where he went and how he did it and who he was with and what happened and how he felt. And every little bit of it is here. There's no guesswork to do. Now, anyway, he was told, go back and say, leave me alone, don't worry, I've got to go to heaven, God wants me, I'll be back, don't look for me. He did. He went and told all these people. And then they came and got him. Now, so he's up in heaven. And then he wrote 366 books. 366 books. And it goes all through this, and I will go all through this too. But I'm going to leave it a little short this time because I want you to start thinking. If you understand electron flood theory, which by now I hope you do, because if you don't, you're missing the whole thing. These little tiny particles make up every single thing there is. There's no big protons and neutrons. There's 1,837 particles in the smallest atom that exists, which is hydrogen. And guess what? 7 heavens, 7.83 is the first Schumann frequency, and that is the heartbeat of the human. And here is the 7 heavens of 1, 2, 3, 4, 5, 6, 7. Those are the 7 frequencies that are related to the Schumann frequencies. Now let's look at the Schumann frequencies. Now, and then it's, obviously you know by now that the Earth scrubs through the particles that are in space, which are emitted from all of the, because they're particles. And I've shown them they're particles. They accelerate, they decelerate, no question anymore. They have a polarity, a positive and a negative polarity, and they back-to-back make up photons. Also, at this point, undisputed as far as I'm concerned. Nobody is disputing it. And they have admitted that the Bohr model is not right because they can't account for these particles that they're finding, which I see now. The positive and the negative are not just one bar magnet like this, and they can't separate. They can separate. The positive can go away from the negative. When they hit something, the black ball just rolls away. And that is the weak force and the strong force. And there is a little bit of a difference, they think. Or I don't know what they think at this point. But what they can't account for is what they call universality. They're missing, if you start with something, 10 of these and 10 of those, you can break them up. But when they come back together, you still should have 10 of these and 10 of those. If they come back together and you got 8 of these and 12 of those, you got a problem. And that's the key. So they got problems, and they got problems all across the board. And they have to start looking about the ancient texts. I have the evidence to support every single word I'm saying, and they have no evidence to stand behind their refusal to discuss. And their refusal to discuss is an indictment of wrongness. All right, I'm going to leave it at this. Everybody knows about I hope you know about it, the electron flood theory. Nothing but electrons exist. They turn into photons. Photons smash into our atmosphere of particles here, which is nothing more than particles. So they have their white portion, it pushes back. And that's all it pushes. Forget about the black portion. Forget, it doesn't mean anything until they get back together. So there'll be a black portion, but forget that. We will see that very clearly, but you also see the white portion very clearly. And the white portion is the active portion. So let's watch that portion. Boom, turns white, pushes down this way. Boom, turns white, pushes down this way. So those go down. Boom, turns white. Boom, boom, boom. And then the Earth accepts them eventually. So that's where the electrons go. Now, the electrons are the only thing that exists in the universe as far as I can tell. There is nothing else. It's just the electrons. And I'm pretty certain of that at this point. And all nucleuses are made of masses of electrons. All right, so that's what a nucleus looks like. It doesn't look like one big proton and then one big neutron. It looks like thousands of tiny electrons together. And that's what creates the nucleus of everything. Now, I'm going to leave it at this. There's 7 zones, and they talk about 7 heavens, and these are all frequencies, and they talk about the light and the dew and the mist and where the light and the heat and the ice and the fire exists, and that's exactly what exists out there. Ice and fire really It's not fire because it's not combustion going on, but literally it is fire. It's the heat of electron interaction. The ionosphere and magnetosphere, that's what it is. It's an interaction of electrons, which is fire. It's combustion. It's the merging of matter. Because light is matter. Light is matter, and light can give off electrons. I'm going to leave it at that for now. Although we are, I don't know if you can see that. Can you see over there? We're going to get into how to use a meter and how to all of these different voltage, amperage, ohms, and you know how it works in a circuit and how things overheat and all of that stuff. Just so you get a basic understanding of electronics, and then we're going to relate it to what is currently thought and really what electronic flood theory demonstrates is true. And I'm pretty sure I can stand up to anybody. Anybody wants to come to talk, or I'm ready. I can't get anybody, not a single one of them, on the intellectual side to engage. So I don't know what to do other than just keep running my mouth. So run I shall. All right, you know my assertion is that all the nucleuses are built like this of electrons. Every one of these would be an electron glued to the other electrons until they hit a stability mass, and I will show that in the salt experiments in a minute. However, what I want you to see right now is how electron works, electron flood theory works, because a light is nothing more than two electrons together, and it makes it back-to-back. Half of that is an electron. I got one somewhere. Here's right here. That's an electron. And again, I think I've talked about this, but reinforcement is reinforcement. This particle is an electron. If you push this with a negative force against this, like in other words, a red force against that red force, it would repel it. If you put the positive force against it, it would attract. Now, the attachment to itself is a weak attachment. It really is. It seems to me it's weak, because when they concuss, the strong force particle, which they would call the electron, disassociates to some degree. But usually it's in the configuration of a photon. So it bounces, because it's already attached back to back. This wants to be into something. This wants to incorporate itself into something, which it can incorporate into a little bit of heat or electricity, static. Right? Or if you flood the hell out of it through something, you get electricity, and you run your vacuum cleaner and you run your electric stove or whatever you got. But you're pushing zillions of them through there. And I mean literally. All right? But these all come from atoms, and in every atom, the nucleus is a bazillion of those particles. So we got a whole lot more to deal with. And all of the flood that's around them is nothing more than the warmth that you feel is extra electrons. It's bazillions and zillions of extra electrons. And if you pulled every single extra electron and you ended up with only what the nucleus would support, which is the helium, it'll only support 2 extra electrons. If you took every other one out, and they did this now, they call it the 5th stage of matter, Bose-Einstein condensate. All it is absolute zero. And absolute zero means that there's no extra electrons, absolutely zero extra electrons. So there's nothing to push back against. So it becomes superconductive. You put electricity into that and it says, oh yeah, man, I usually have a lot of electrons. Come on, shoom. And as soon as they come in, they start pushing back. So you lose your superconductivity instantly. Now, if you kept it cold, that means you keep sucking those electrons out. They just keep flowing them through. But then you've lost your superconduction, free superconduction. Somehow, well, it's a whole different issue. Let's not bother with that right now. But here's what happens here. We know that started out like this, because we saw it. I saw it, you saw it, we all saw it. We all love ice cream too. Well, I do anyway. When this comes through, it's separated. It's just, there's no question. If you can't see that, then you really got a serious issue with your eyesight. If you see any blackness there, I want you to tell me where it is. Where precisely do you see it, mes amis? I see the little black balls that we saw were attached like this when they came in. And they would call them muons. And they would call these explosive ones electron showers. That's what they're saying, and I agree 100%. And a Venturi is absolutely, no question, known to accelerate. And when they show that V, and then they show E, and then a V and a muon, it means it's an accelerated high-energy particle. It's not just laying around particle. A laying around particle just lays around with the rest of the particles. If you have ambient temperature, nobody's pushing, nobody's shoving, everybody's happy, they're all the same temperature. There's nobody swelled up pushing against somebody else. And there's nobody says, "Ooh, I'd love to have that, I'm cold." Right? I'm just the same warmth you are. We're all equal around here. Just everybody lay back, take it easy. That's what happens when your ambient temperature is normal. When you get something that's cold, it wants to warm up to whatever its surroundings are. And this is nothing I'm saying. There's no disputes here. So we are pulling out or pushing in electrons. Now, the electron is, as I say, a polar molecule. It's a polar, it's a polar subatomic particle. It's smaller than an atom, and it's not, the protons are made of them. And I'm going to show you right now how protons are made and how electrons form together and why I think the Schumann resonance is really, really critical here. Now, getting back to the reason that they have lost universality of because these are leptons. They call these leptons. They got so many names. But the leptons don't come back together in the right numbers, apparently, is what they say. I don't know how they figure this out. But I can tell you one thing right now. I always thought that when these were attached together, which is all nothing more than a bar magnet. And I always thought if you broke apart a bar magnet, it would have a positive and negative end. And it does. However, this appears to completely disassociate the positive from the negative particle. Because we're down at the particle level here. We're at the smallest electron level that exists, that I know of. Except for when we break it apart, it's these particles. They are smaller, yes, I agree. They're half of each one. And we can see them as those black balls. I'll show you the green one. The green one is absolutely amazing. Well, let me show you the red one, then I'll show you the green one. But here's the key to the whole thing is that these are separating. Now, when they come back together, the black ones don't always come back together with the white ones in the same number. Now, are they calculating it down here? Because it's downstream here is when they just come back together, you see? Eventually, they want to come back to the white ones. But until these guys settle down after the Venturi. And don't forget now, the Venturi is a drum of metal here and a drum of metal here. And that forces everybody to skirt its way through that swish. All right? And then they force into each other and they say, oh no, and boom, they just go. Now the black ones say, I'm not getting in the middle of this. You guys do what you got to do. We'll meet you later. So you see them sort of skirting around the edge. Now, whether they're skirting around the edge, obviously they've become disassociated. So my take is that these black balls were at one time, just a moment ago, attached to the white particles that I'm showing in red. Black and red is black and white, really. Now, let's look at some other things. I mean, I don't know really how much more I can go with this other than to say that they have completely separated from each other. That is charge separation. There's that particle there there's no interaction. There's no interaction. And they don't mind touching each other. They don't mind being on top of each other. They are the things that migrate to the center of nucleuses. And I'm going to show you that happen right now. And when they migrate to the center, all the negative particles will surround it, and they will keep more negatives from coming in, because they want to get into that mass now. So more want to come in. They say, no, no, no. We've got so much push back against you. So it's push and they shove back, push and they shove back. So, and there's going to be a certain number of pushbacks in here to what they're pushing, and that'll keep them at a quantum distance. And then there's then those levels, and I believe they're related to the Schumann frequency, because there's 7 levels and there's 7 Schumann frequencies, and all of these frequencies relate to how that electron vibrates in that range, and what that range of these particles, because there's zillions of them in that range, bazillions of them. Let me show you how they work. And salt is going to be the electron. All right, where do you see this? Okay, just to prove my point, this is just 6 months or so ago. Could the standard model be wrong? Lepton universality is violated, and yes, it is wrong, quite wrong. Right about here, she says it here.
And lepton universality seems to be violated. Well, what that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics. There's absolutely no way that we can explain this observation with our current understanding. In fact, the only way we think we can explain what's going on is if there are new particles in the universe associated with new physics processes beyond those that we understand, and that these new particles are interfering with the B mesons as they decay and suppressing the decay to muons compared to electrons. Now,
all right, muons and electrons. Let me just show you quickly what they are. We've captured them quite obviously, and they can easily be they completely separate. So it's not like they are particles that are attached to each other. Some may go in and exchange their value for something else, and apparently that's what's happening. All right, same thing about 6 months ago. Can new boson appears in nuclear decay break standard model? Well, yes, we have that boson. That boson is called this weak black particle, and we've shown it, and I'll show it again right in a second. But it talks about this. It says it's been smoldering for since 2015. In a publication, they said we see that there's no, we can see this particle, and nobody would accept it until, I think they do it because I can show it. I can show it very, very well. All right, if you remember, she talked about muons and electrons, muon neutrinos, electron neutrinos. The muon neutrinos is the black ball, and the electron neutrino is the white ball for us. When it concusses, it turns into electron showers. You see it, this smashing? This one here doesn't do anything. It just keeps a black ball, and it does. This is the one. It turns into a shower. That one just rolls away. And here, let's check it out. Okay, I'm not going to dwell on this because I've shown it a zillion times. Now, this is the pulse red laser. Bip, 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 bip. It accelerates. It explodes at the venturi. Out of the venturi is the white concussive particles that spin. There they are right there. And around the venturi is the black balls that will not enter that venturi. They will not get in the midst of that. They separate the electron, which they would call a muon, from the electron, which is the concussive part. And I can't disagree with that. But we can accelerate light. We know they're a particle. In here, it was not a particle. I mean, it is a particle, but we see it as a wave. You see that? That's what we see coming forward. Well, it's because everything in the front of it's got to get away from its magnetic field. But the particle is only there. Now, as it accelerates because of a venturi, fully understood how a venturi works, it pulls the actual particle out of the wave, which was over here, the wave. Now the particle itself is being pulled from the wave So we know it's actually a particle, and it concusses with its head-on particles, which are trying to force their way through, and accelerates them, and they become extremely explosive. And before they went through there, they look just like this. And here they are right here. You see, there they are right there, just like that. And they have a dark and a white, a dark and a white. And that is a photon, and it was the red photons. Now, if you had a green photon, and we have identical, actually identical, only they're green and they're more powerful, and they concuss further out than the red. The red concusses quite early because it's weak. Now, but otherwise you would know no difference at all. And you can see this is the right-hand spin, means it drifts to the left. It's expanded, concussed, so it's slowing down. Then we have a very, very unusual event where a reverse spinning particle did this. So there's a lot of stuff to talk about here. But let's look at what happens at the Venturi, because that's where the real action is. All right, this is amazing resonance experiment. It is BrustPup. Now, I say this also demonstrates resonance frequency vibration. Now, you see what she's putting on here is salt. And what is salt? NaCl. What does that mean? It's completely polar. So what does that mean? That means that there's a negative side and a positive side. So if I push it with a negative, it's going to push it away. If I hit it with a positive, it's going to pull it down. So I can literally shake this up and down if I could vibrate that, because vibration is nothing more than, up and down is nothing more than push of a particle up and sucking it back down again, which is the same thing as a magnet does. Push it up and bring it down. So this, when they put a vibration in here, they're putting a frequency. Up, down, up, down, up, down, up, down. And this is going up, down, up, down, up, down, up, down with it. Okay, so at a certain number of shakes, these will start to shake, and then they'll say, "Whoop, that's right, you're good, 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 good. Oh, okay, you're good, I'm good. We'll stay right where we are." And that's called resonance frequency. Now watch what happens. All right, I've got to turn way down. Here we go. Now, they're going to vibrate the metal plate by using a tone generator. A tone generator, even when you're talking, it's nothing more. The tone increases, geometric patterns show up. Now, this is nothing more than injecting a voltage into this. Now, what has happened? These salt particles, in my world, literally are electrons, because they have a weak and a strong force, each one of them, as I showed you before. They are NaCl, one side and the other. All right, which makes them, and each one of those molecules, it's a molecule. First of all, they're atoms, one of each Na and a Cl. When you put them together, they make a molecule, and it's a polar molecule. It's just like a bar magnet. It's just like one of those bar magnets. Now, when you shake this tone generator, you're doing nothing more than making a plus minus, plus minus, plus minus against this plus minus, plus minus. And it'll eventually, they'll settle in at a certain frequency, which means how many times per second it's shaken. And this is 345 hertz. You start out with literally in your hydrogen helium area, which has just one core and then enough to have a couple of electrons in the first region. Then you jump up to the next one, which is, then you go up to the rule of 8. You see, 2, 4, 6, 8. Now, and then it goes up from there. There's 8 in the valence shell, and they get extremely elegant. But there's 7 groups that go across. Each one of these, I believe, is a Schumann frequency, a Schumann resonance frequency. And you may be able to test this out if the geometry of this wasn't square. It might have to be round. It might have to be a sphere. I don't know exactly how you would, but that's why I'm doing this. Somebody can figure this out. But watch what happens. It goes from 345 hertz, and it locks in. Boom, we're good. Now they're going to put some more stuff. Now we're going up to the rule of 8. And at 1033, You see it? 1, 2, 3, 4, 5, 6, 7, 8. And then there is your lower orbital, which is the s orbital, still down here. And you have your central core, which is the deepest little spot, holding on to this region, and then you have 8 of them in that region. And then it goes up to the next region. They get more and more sophisticated, and it's just an increasing number of hertz. You see them? They get more and more and more and more and more and more and more. As you increase the number of cycles per second, they just keep getting more and more and more and more sophisticated. But you always have that core, and then you always have something that you could figure out to be like a rule of 8. All right? Like you could go 1, 2, 3, 4, 5, 6, 7, 8. It makes that. And then there's more out here, and then more out here, and then more out here. That's your different regions. All right, this is crazy. This is Latham's crazy machines. This is the incredible tractor beam magnets. Now, I claim if we could get a negative core in the center, which is capable, because we can see those black poles go all by themselves, they would be surrounded by these negative particles. So you have, did I say a negative center? It would be literally positive, and because we're calling these the electrons, and we're calling these the muons. The muons move to the center, the electrons surround them. More electrons want to come in, attached to muons. They come in and they want to get to these in the center, and they say, oh, no, 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 we got just enough. We're good, we're good, we're good, we're good, stay out. And they hang out around the edges in these little crevices, as I will show you. All right, here it is. Latham's crazy machines. Now, what they're going to do is make the core, they're going to put one in here that is going to be the negative. These are, I keep doing this. They're going to put one in here which is the positive, non-combustive ones. The negatives are out here that surround it, and they're going to push more negatives away to try to come in. So they're going to put one in the center of that, emulating exactly what I talk about. So here's the outside. The brass ring has 6 neodymium magnums in there. Boom. That one there attaches to that one. They're going to put it in the center. Now, so you have this one that's going to attach, see? Now, in between each one of these magnets, there's a zone of magnetism that is going to keep this one attached to it there at a distance. It's exactly electron flood theory. And you could shake it, it'll warm up, and then if you shake it enough, it will eventually escape. And if you really slam it hard, it will take off hard, and it will become light, and it will become very energetic, and it could become damaging ray. But watch. Boom, it took off. That would be considered heat or light, and if it comes out fast, it's light. See, there it goes. Now that would be considered maybe light, and then faster than that would be considered a damaging particle. Okay, my friends, Roger once again, Mudfossil University, and I finally discovered exactly what causes gravity, and it is the dark matter and dark energy and the dark particles that are the black balls that attach to the white concussive particle, and they look like this. What we did was we sent a red laser, pulsed light red laser, and it accelerated. We could see it accelerate, as you can see it accelerate right here, into the venturi, which is 2 round metal drums, through that slot, which they're curved, so it forced them to concuss, and it separated these black balls from the white explosive portion. You see the black balls? They're not explosive. And then they come back in down below and add back into the white. So in this area right here, we have literally 100% energy. These are the non-energetic particles, the black ones. They don't mind being against each other. They'll touch each other, no problem whatsoever. But they want to be attached to a white one. Eventually, when the white one settles down enough that it can attach its weak force back to the strong force. But during the interaction, they separate, as is obviously seen. There's no question. There's absolutely no question whatsoever. Because I can show you what they started out as, and they started out as particles like this. And they will separate to particles like this, and then, which is an electron, this is a photon, and then they will separate to particles like this, which is what they call a boson and a fermion. The fermion is the explosive part, the boson is the black part. It's exactly what they're looking for, and it's exactly what I am showing you. And it works because of electron flood theory, which says the nucleus is solid electrons. No protons, no neutrons, just electrons. Now, there are zones of stability, which are quantities that relate to the number of protons and the number there is in neutrons. Now, there's 1837 in a proton, and there's 1838 in a neutron of electrons. Now, helium has 7,350 in the core. This gives us elegance to do all the things of life and all of the things that materials do. Otherwise, you can't do it. You can't do it with what they had before. First of all, it's impossible that the nucleus is 100% positive. Never worked. I knew this from day one. Absolutely impossible. It had to be a dipole. How that worked out, I didn't know. But after seeing light accelerate, seeing light separate, seeing light as a particle, understanding that nothing that we were told to base our assumptions on was right, now we know what to base it on is the fact that there is nothing but electrons, and they make everything up, and every molecule is only a mass of electrons at a certain frequency and a certain quantity that it becomes stable. And I'm basing it now on the Schumann frequencies, which create stability, I believe, in molecules. Something's making them shake. Something's making them shake. They're not just shaking by themselves. And we know that the Schumann frequencies, and well, let's go look at that. All right, I'm not going to get too deep into this. I did the thing on the Schumann frequency the other day. You see the Earth is at the bottom, and then you got 7.8 or so hertz starts the first layer of atmosphere, then the next layer, then the next layer, then the next layer. Those are the Schumann frequencies, and now I'm starting to believe that they relate to these groups on the periodic table. So hydrogen, let's say, is down here or out here, I'm not sure which, but each layer here really basically relates to one of these because it's a pressure zone. And it's going to have a certain frequency, which is, it starts at 7.8 and then you add like 6.5 or so between each one going out. And well, your hydrogen is going to be way out here, right? Because that's the least heavy element. So you start out here, your hydrogen, then your lithium, and then your sodium, and then so forth, going down towards Earth. And Earth will always attract the electrons. They hit the Earth. Earth is Earth ground. That means, give me your electrons. Now, I went over this the other day, so we're not going to get too deep into this. But it's electron flood theory, and it accounts for all the particles that hit us. It accounts for our Earth spinning, creating our magnetic field, our magnetosphere, our ionosphere, the layer of electrons that pushes the next layer down, that pushes the next layer down. It's push to shove, push to shove, push to shove, push to shove, and then the Earth takes whatever gets to the Earth. Now, that's why lightning collects in these different layers and shoots down. Now we're getting overcharged in some of these areas, and there's red sprites, and now there's even blue jets. The blue jets means they're more energetic. So first it started with the red sprites not that long ago, and now there's blue jets. That means the Earth is literally overcharged, and it does not want any more electrons. So they try to go back up, and they just don't. They won't go back up because we're scrubbing against a layer of electrons and photons and dust from the sun and whatever else is in the solar system. It's there. The light comes to us, and I've shown us particles. It's particles. They're particles. They're not just nothing. They're not just waves of nothing. And that's the problem. We were taught to believe something that we have to go by to start our thought process, and now you can't get to the correct answer. Even the guy at Yale. Well, watch this. This is kind of funny. And I emailed him, and I had hoped he'd email me back because I thought he was going to be. I thought he looked like a kind of honest guy. He never answered, so who knows? Okay, my friends, this is Yale, and intuitive means something you can understand because it makes sense. Well, he's telling you that quantum is not intuitive because the way they have it interpreted, it doesn't make sense, and it never will make sense until they consider electron flood theory. Now listen to what he says, and this is Yale.
So this is a very exciting day for me because today we're going to start quantum mechanics, and that's all we'll do till the end of the term. Now, I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively, and the good news is that nobody can follow it intuitively.
Exactly. It's impossible to follow intuitively because a positive attracts a negative. So if this whole core was positive, which they say it is, the nucleus, and then the electrons were negative, they would just collapse in on themselves. So it never made sense. This has to be a dipole, and it has to have so much energy in there of the extra negatives that surround the positives that the more want to come into these positives, because these are the collectors, these are the gravitons, these are the dark energy that wants light energy to attract to it. It's just come on over here and we'll snuggle up and we'll just be friends, and everybody can get together, and they will always go to the center, and the white ones that attach to them will surround them. Then the new ones coming in will be pushed away at a certain distance. Look up tractor beam magnets. It'll blow your mind. It shows them they make one, and they use a positive center, and they put negatives out here, and then they put more magnets around it. Bang! It comes in, and it's just like a half an inch away, and it stays there. They shake it all around, it stays there. Just totally suspended in air, just like that would be. Now this, I'm not making these things up. Look it up. Tractor beam magnets. And then also look up vibrating salt experiments where they put it on a salt table, and a certain frequency, a certain number of loops will occur. And that is nothing more than quantities, because a salt table is nothing more than positive, negative, pushing up and down against the salt, which is positive, negative. So, and then finally it stabilizes. All right, so this stuff it's pretty well understood now. It's time to start taking it a little more serious. Otherwise, they're just looking at things, and this quantum, that's fine. You can tell the kids anything you want. And if they say what you tell them, you give them an A, that's great. But if they're telling things that aren't right, what's the sense of that? And if you won't even agree to look at what is presented, and with the evidence I have, including evidence that is extremely hard to
Richard Feynman, one of the big
dismiss. Literally can't be dismissed. Whoops, that's a whole everything. Anyway, and then we can even use water to cut steel. And the reason you're using the water, it's not using the water, you're using the hydrogen. When you put it through the nozzle at such an extreme compression, you actually separate the hydrogen from the water. When they recombine, that's nothing more than electricity. And it's electricity that can cut titanium, tungsten, literally anything, granite, wood, rubber, anything, because it's nothing more than electrons. When this first started out, it was a ball, looked just like that, a wave, and that's the particle. That's exactly what it looks like. And when it accelerates to get to this Venturi, it pulls itself right out of that wave shape. It's only a concussion out here. So that's what we were seeing here, is the concussion. And then as it had to speed up, the particle literally pulls itself right out of the wave and into the venturi, explodes, divides, and the black portion, which it actually gets seen as this, and there'll be a black and a white here, and as it hits the venturi, the black portion, which is the non-reactive boson, slips away, and the white explodes, because they do not want to be next to each other. That's the strong and the weak force. Alright, I said I was going to show you those photon shots. Now, might as well give you a couple of shots along the way. You saw it accelerate, you saw the black separate, you saw the light wave, you saw the acceleration, and so forth here. Some of this stuff you didn't see. That's the chaos, that's the rainbow showers, that's the Higgs on the move, pretty cool. That's the mini one. That was that little crazy piece. This shows that light spins. You see, it spins. That's what creates these interference patterns. They don't want to be next to each other, and as they spin, they say, you get away, 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 and then they sort of trail off. And that's what, and they know this light spinning now. I was just watching a thing about light spinning. Now, here's the red electrons. Now, here's what happens. You can see them, and as I showed before, this is the particle coming here. At first, there's no real definition other than there's some darkness and some white. And then it starts to show up as the box that it is. Then it gets brighter, and then it gets that little spikiness to it. And then right here is where it separates from the black and white, and the white particle goes through the venturi, and the black separates away. Now, the green also does that. Where's the green here? Here's a green electron. Same thing, it's identical, only it's green. Now, and it concusses way outside of the venturi because it has extreme amounts of energy. And here it is right here, compared to the red. I believe the venturi is here. Now, Rod did the experiments, but I believe this is where the venturi is, and this is where it starts to get really fuzzy because it's starting to separate. And until it hits there, it's accelerating. Now, it starts to show itself as a particle way back here, but then you can see it. You see how crazy looking it is? And they're coming in from every angle, because that's, the other one was just, he captured just that one red, but they're coming in from everywhere. What else we got? Anything good to show you here? Here's what they are. This is what they look like as they're spinning down the red. See it? Swish, swish, swish. You see them on an angle? It's nothing more than spinning, like a spring. I have a spring around here that I show. Hold on, I will find it. Or maybe I won't. Yes, I did. Here. You see, it's just basically like this. So you're seeing it as almost like a wave, but it's really a spinning particle. And it's spinning this way right here. Spin, 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 spin. Now, and that's red. And of course, if it was green, it would be a different color. Green. What else we got here? Anything good? Oh, here's the red and green together. This is Fabian. Most of this was Rod Warren did the experiments on the light. Fabian Brule did the red and the green together. And that's the actual particle beam. I'm almost 100% sure. And you see it's being pushed away and pushed away. I believe they call it the Lorentz effect. And it's because of magnetic field effect on light. But what to remember here is, you see there's a little tiny red spit somehow got caught up in here. And here's the green ones. But mostly it's being pushed away, the red, because the red is not as concussive as the green. And the green really didn't want to concuss until it got out here. But because this made turbulence in here, really, that's what causes this reaction here to interact with the reds coming out of here. Otherwise, you wouldn't see this, I don't think. I don't think you'd see that until it got way out here. Maybe you would, I don't know. I haven't been doing the experiments, so and this is easy to do. This is right through a very simple little venturi, which Rod used two literally nails, side by side, right in front of the red laser, and put it right into the Here, I'll show you. Hold on. This exact, I have all the same stuff he has. All he did was he took the pulse red laser like this. He put a venturi right in the front here, the two nails, at least in some of the experiments. And he literally glued it on in the front so that it was like this, the two nails, one here and one here. So he had a little bitty slit between them. And then he took this and he put it right into the selfie of this Galaxy S3. Galaxy 5, 3, Galaxy S3, I guess, is Samsung. And then he did sort of different things looking at it in different directions and so forth. And then, of course, somebody else did this and somebody else did that and somebody else did something else. And once they realized they could do this, very, very simple. And then, of course, you can other like the other, you know, any laser I think is okay. I'm not doing these. I'm not going to bother. I get so many people sending me this stuff. I don't need to. And, you know, I have so many other interests that I can see what I need to see. I don't need to do this myself to prove that what I'm seeing is what I'm seeing. I understand what I'm seeing because I understand how these particles react against each other's fields. They're nothing more than a field surrounding that particle. Now here's the problem with CERN. They think there's something different about the nucleus than light. No, there's nothing different. The nucleus is made of the same particles that make up light, and they're seeing them as light. They understand they're light. I mean, I'm pretty sure they understand that leptons and muons and all those things are particles that they would consider light. They interact just like light does, only they're starting with gigantic pieces like this, and they're just looking at chunks like that, and chunks like this, and chunks all over the place. We started with that particle right there. Right? We started with that. That's like what they have right there. Actually, it's like this one right over here. They're trying to find that particle, digging through all of this stuff, and then they find one. They say, "Ooh, look at this! Look at this! We found this! Woo, 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 woo!" Well, we started with that woo, 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 and then we made it into a black one and a white one. So woo, woo, woo on that for a while. Now, once again, that is because of my attitude. I don't mean to be this way, but there's no engagement whatsoever from the people you would think want to be engaged in this. I think I'm showing something that's pretty valid, and at least, you know, because I've reached out. It's not like I'm asking them to come after me. I am continuously, literally every day, sending this kind of stuff to geologists, to physicists, to electronics people, to experimenters and everybody, and literally nobody responds. None. Now, why? I am not 100% certain, because I would expect somebody somewhere, well, the ones that do respond are negative. They just don't want to have anything to do with it. So that's all I could find. That's all I'm finding. So that's why I have that kind of an attitude. I'm sorry about it. It's just going to be the way I have to do things. Okay, maybe I showed you, or I will show you, the atomic bomb going off in the atmosphere. Same as this. This is an electron discharge through a cloud chamber. Well, look. 1, 2, 3, 4, 5, 6, 7. Basically 7 rings I'm looking at, which are resonance rings. To me, it's like the Earth, the Schumann resonance around the Earth. That's the black spot in the center. This is where the concussions are happening out here. There's a clear separation of values here. Now, where the concussion is, I would have thought the bright spot would be the concussed area. So normally I would say that's the concussed area, and that's the concussed area. And this is pushing back the black between. It's push to shove, push to shove, push to shove. And the black is able to push and shove and doesn't get mixed up in this energetic region. So I believe that's what's going on there. I believe the black is acting as an intermediary between the two regions. It's pushing down and banging these electrons, and they're banging back and leaving a dark side to them, and then the white side of this one is bang. I don't know. It's somehow it's push to shove is all I can say. But those are, as above, so below. And I'm relating all this stuff to what was written. And, if you can't see what's going on, I don't know what else to say. Look at this, look at that. I just noticed this, boom, boom, boom. I bet you there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8, I don't know, whatever. But look, something in that is it. Look at that. Look at that. This is interesting. Now that black has something to do with that. That has something to do with a more glowy white. See, it's more glowy white. It's attractiveness to that. This is trying to get in there. Very, very interesting. Very interesting. And what's going on here? What's going on there? Yikes. There is a lot to look at here. A lot to look at. And I'm going to tell you right now, the glowiness is push to shove of the white electron shower, electron neutrino. And the other one is just the mediator. They don't care about hurting anybody. They just want to get away. They don't want to be involved in this. They just move to the outside. That's what I'm seeing. It's an extremely explosive event of an electron discharge into a cloud of vapor, which I believe is usually alcohol vapor, something like that. And it just, now watch what happens with atomic bombs. Okay, by now you should understand what's going on. The Earth is scrubbing through the particles in space, creating a scrubbing effect of more or less a generator. It's scrubbing electrons into electrons. That creates heat, that creates the magnetosphere or the ionosphere at the far out range, and it pushes hard against the Earth during the day because the sun is pushing it more. At night, it gives you this trailing effect. So they call it the diurnal effect. Now, here's exactly, and you're going to have to go looking up this up yourself, and get your book. Get a book and write it. Write all. Look, get yourself a book like this. Just. I know this stuff very well. I don't care. I have to keep writing this because it keeps changing daily. The more I look, the more I understand. And if you don't write it down and be able to edit what you put in there, your mind just gets into a big boiling mess. Believe me, I've been in a boiling mess for a long time, and it's the only way to sort it out. And even that, it's... But when you draw a picture of what this push to shove would look like, and if you feel them coming at you this way, what would you do coming back that way? What would be the interaction of the molecules? And I got to show you, a guy took a little ball, and he was a really heavy guy, so he had a lot of fat on him, which has a different density than water. Water is uncompressible. You cannot compress water. Literally, it's so uncompressible, it's like hitting a solid rock. He jumps in the water, boom, the ball goes up like a rocket ship. And I was trying to understand the forces in action here. And his body actually, well, let me show you the thing. It's unbelievable. Oh, it's just absolutely amazing. Manu bomb. Biggest ball bomb ever. Watch this. This will blow your mind. Now, don't forget, he's jumping into water. Water is incompressible. Now, it's going to move out of the way as he hits it, but originally his girth here, because he's got a lot of excess flesh on him, which is not really flesh, it's fat. Now, that fat has a certain density to it, and the ball is going to be sitting on his stomach, and it's going to go off it's going to gain a lot of energy. Let's put it that way. Watch this. That thing almost went into orbit, man. Can you know, that's just amazing. Now, what is going on there? I'm trying to analyze it, and there's a couple things at play. The water is going to become a wrapping around him back like this, shooting up, hitting itself. And don't forget, water's incompressible. So there's a lot. And now I'm going to show you something in the slow-mo, guys, because it may even be that he's creating sonoluminescence. You can create that in the cavity of a water, in a cavity of water. If you're in extreme sunlight and the sun fills the cavity with electrons, you may be able to get that kind of energy. Watch it one more time. Then I'm going to show you why I say that. Boom. Look at that thing go. My God. That is just amazing. Now wait till you see this. Now, I talked about layers of atmosphere. Watch this. This is the Tsar bomb is deployed, and it's going to explode, and you're going to see layers of atmosphere. And when I say layers of atmosphere, you're going to see the layers of the Schumann resonance layers. And they're going to show up as brilliant white, well, not brilliant, but they'll be glowing white layers. And the reason is because when that bomb went off, it releases all these electrons. And those electrons crash into the water particles or whatever well, they're not necessarily water particles. They're the zone in between the next layer. So that's pushing, that's shoving. So you have a layer of literally electron to electron here, pushing each other. Now, when this comes up through it, boom, the whole thing goes up and you see a glow. That's because it's electron to electron. In the middle, you have the dark region. And I believe that's what you're going to see. Watch this. Man's supreme achievement. I don't know if that's 57 million megatons. But it could be. It's 57 million tons, maybe. I don't know. Watch this. Now I'm going to click it here and there. Boom. What just happened? What happened was they had so much material, which is supposed to be spread out in different atomic orbitals. They had this stuff crushed so tightly together, there was no room whatsoever for anybody to get anywhere, and they all wanted to be apart from each other, and then they clad it with something so serious that it couldn't be breached, and then they collapsed it some more, and then they put explosives around it, and then they concussed it. And it does this. Well, what happened? Well, at that point, it says, that's it, I'm done. They all come out. Now, they're coming out as particles. Not only are they coming out as electrons and photons, they're coming out as chunks and blocks of things and all kinds of stuff coming out of there. But primarily in the atomic realm. Now, so here it goes off. Now, watch what happens in the atmosphere. Okay, so far nothing, glowing like crazy. We're seeing a little something going on now. Boom, boom, boom. Those are layers of atmosphere. Boom. All right. That is particle to particle interaction, the white parts, not the black ones. Just the white ones. And you can see it's like kind of dark around it. Whether they're getting out of the way, I don't know. You see it? How dark it is around those white stripes? All of a sudden we're going to get concussed. Boom. You see the darkness here? See that? The darkness up there? That's the dark matter, dark energy, whatever you want to call it, and now it's sort of dissipating back out, just like Rod's experiment with the Venturi. Now I have another one here, hold on. All right, this is from Wired, And this is rare nuclear bomb footage reveals their true power. Now, they recorded this extreme slow motion, and I got to remember to do the slow mo of photoluminescence. And I'll show you that. There's a cavity forms and it fills with electrons, and then when it comes back and crushes itself, it's nightmarish. Now, nuclear physicists using film scanners and computer analysis and old bomb tests to uncover weapon secrets. Now watch this. I just ran into this. I don't know how. I just did it by accident. Listen to this. Now,
on July 16th, 1945, the United States tested the first atomic bomb, called Trinity. Over the next 5 decades, the country tested more than 200 bombs in the atmosphere.
Look at that. You see that? Those are something that was forcing this in, and there's the dark particles collecting. I think they're going to end up in a mass somewhere. And these are the concussive white particles. And they have some absolutely stunning...
The explosions called shock.
Watch this. This was a nuclear ball of electrons. And all into, uranium, plutonium, crushed as much as they can. So there are particles in here which are atomic particles that have some stability. And that maybe is what we're seeing here is the stable ones punching through. I don't know.
Were recorded by...
You see it? That is the same architecture. I believe this is the same magnetic signature. And it's not, right now is nothing but magnetism going on here. What exactly magnetically is going on? I can see white particles separating from black particles, it looks like to me, and I can see bubbling, whatever that is, and I see these spikes. Now, something hard got pushed out of here, heavy, something real heavy got pushed out, and that is a big, heavy one too. Only this one is much bigger than these, I believe. Now let's watch. I'm going to do it slow.
Dozens of...
All right, you see it again? Now, already, the energy is leaving.
high-speed
You see it's getting dark already.
cameras on
See it?
film for analysis.
Now, there's our light energy. There's our darkness. Now, this is not a natural event. This is a totally unnatural event. But you could see even the black and the white here and the shape of it, hex.
Of the bombs.
Look at that. Now, I don't know how big that particle was, or how big that bomb
Destructive
was.
power.
But look at that.
Now there's a race on to preserve and digitize those films. Thousands of them.
So some of the cans that we opened up, especially the Trinity films, are quite old. Those that actually turned to dust. And
Well, look at this. Now, here's another one. What's going on here? What are these stripes in the atmosphere? Why are they going straight up? Where did this take place? What was
this
the...
particular film was running about 1,500 frames a second. So we not only captured the shock wave, the reflected shock wave, we're also able to get the yield off of it, and now we're also watching how the mushroom cloud formed.
Now, don't forget, anytime you see the white or the white, it means the concussor, the concuss. Now, look at these things really carefully. You can see that there's some structure to them. Look at this one. Look at that. If you go like one little flick at a time.
Sprigg saw his first atomic bomb in 1962.
And there's just some stunning stuff that you can see in some of these old footage here, and how these bombs radiate. Exact, total, 100% perfectly round signature from the blast. And
Is the mushroom cloud. shock waves, or recorded light intensity of an explosion in a bomb film.
Look at
And it was
that.
done by hand.
It would have taken an army of workers a month to just get the light pulse off of one film.
And this nuclear bomb.
Look at that.
We're very hopeful that we're going to learn some new things here that they
Anyway, there's, there's so much to look into now with electron flood theory. And again, as I believe I showed, there is no way that the Bohr model is correct. It's just not right. So until you take a look at well, I should take a look at mud fossils, of course. But until you take a look at electron flood theory, then you're just walking around in circles. If it's wrong, it's wrong. Show me it's wrong. I'll listen.